Predictions, models, algorithms. It can feel overwhelming, right? But what if combining models could make them smarter and more accurate? That's the power of Ensemble Learning. Welcome to day 28 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we'll explore how ensemble methods can take your models to the next level. Let's dive in. Let's bring in the power tools. Importing pandas for data handling, NumPy for calculations, Seaborn for styling, and matplotlib to visualize everything beautifully. Time to load our dataset. Let's peek at the first few rows and check its shape. Gotta know what we're working with before diving in. Missing values? No problem. Let's fill in the gaps by replacing missing ages with the median, keeping our data clean and ready for action. Filling missing embarked values with the most frequent category ensures consistency. Turning categories into numbers. Encoding sex and embarked, so our model understands them better. Transforming raw data into something machine learning ready. Removing clutter. Dropping irrelevant columns like IDs and cabin details. Keeping only what truly matters for building a strong predictive model. Time to see the survival split. This count plot quickly reveals how many passengers survived versus those who didn't, giving us key dataset insights. Let's dive deeper. A pair plot shows relationships between features, with colors highlighting survival patterns. Great for spotting trends and correlations visually. Box plot time. This reveals how age varies across passenger classes, spotting trends, medians, and potential outliers in one clean visualization. Let's uncover hidden relationships. This heat map highlights feature correlations, showing which variables move together and which ones barely interact. A goldmine for feature selection. Building a new feature. Family size gives us a better sense of group travel dynamics, helpful for understanding survival patterns in the dataset. Time to split. Separating features and target, then dividing into training and testing sets, ensuring our model learns and generalizes effectively. Scaling matters. Standardizing features ensures all variables have equal influence, preventing dominant features from overshadowing others in our model. Time to unleash the power of ensemble learning. We're bringing in random forest for robust decision trees, gradient boosting for iterative improvements, and support vector machine, SVM, for strong boundary separation. These models each have unique strengths. Combining them can create a powerhouse of predictions. Let's set them up and see how they perform. Time to combine forces. A voting classifier merges predictions from random forest, gradient boosting, and SVM, using a soft vote for better accuracy. More models, smarter decisions. Using our trained voting classifier to predict on the test set. Let's see how well our ensemble model performs. Time to evaluate. First, we check accuracy to see overall performance. Next, the classification report gives precision, recall, and F1 score for deeper insights. Finally, the confusion matrix reveals true positives, false positives, and misclassifications, helping us spot where the model excels and where it struggles. Let's analyze the results and see if our ensemble approach pays off. That's a wrap. We boosted accuracy with Ensemble Learning, but now it's time for real-world action. Next up, a full machine learning project from scratch. Click the screen to dive in, blast off,